This episode, we're going to cover specifically objects and the difference between objects and primitive data types. So what is a data type? Well, we covered data types already, and you didn't realize it. A double variable is a data type. String is a data type. Integer is a data type. They are the means by which you can define a variable by its type, or what kind of information goes into that variable. So now we're going to talk about objects, because the thing is about objects is, unlike primitive data types like double and integer and float, the object data type, like string for instance, and like random, they're much more complicated. They are of an idea rather than a very simple concept that can be nailed down really simply. They are much more complicated than that, and they can have their own instance methods and things of that nature. We're going to go over the development of objects. Now, we have our project right here, Hello World Basics, and to create a new object, we could just put it in the same file we have here, helloworld.cs, but we're going to illustrate the fact that they don't have to be part of the same file. So we're going to right-click on where it says Hello World Basics, our project name. We're going to press Add, and then Class. So here's our class. You want to do class. We're going to call this class person.cs. Add. So here is our class called person. Now you'll see what I mean by objects and classes in a moment. Let's get rid of all these directives at the top. And within the person class, let's put the word public before class. So what does public mean? Public is a way of saying the members of the person class are by default public members. So for instance, if we have any methods, they are by default visible unless we specifically make them private. So within this person class, we can create what is called a constructor for person. So we go public person, parentheses, and then opening and closing curly brackets. So already this looks familiar to you. This looks like a method, but unlike a method, there's no use of static like we were used to, but also there's no return type. There's no void, there's no int, there's no string, and that's because the the constructors are like methods in all the same ways, except they're not supposed to return a value. They exist only to instantiate a class. So what do I mean by that? So when we go back to Hello World here, let me get rid of all this stuff that we wrote before. And I'll get rid of that too. Within here, we can create a object of person, and we can call it anything. We could call it person with a lowercase p. We could call it obj. We could call it orange juice, and we could call it whatever. We're going to call it, in this case, person with a lowercase p, because that's pretty good. That works pretty well as a object variable. And when we do equals new person with the parentheses, what we're doing by saying person and then parentheses is we're referring specifically to this constructor. We can make alternate constructors as well, and I'll explain how that works later. So I can say public person, and we can have a parameter or argument where it's string and then first name, and then we can have another string last name. Now you might be wondering, how can you have two constructors with the same name? Well, they're not the same constructor. I mean, sure, they have the same name, but they don't have the same amount of arguments. If I had the same amount of arguments, it would not work. And it doesn't matter what the argument names are, like in this case. What matters is the number of arguments of a given type. So we can do ints right here, and that's fine, because it's just two ints, not two strings. That's fine. We can do mixed types as well. That's okay. What this is called is overloading, the practice of being able to differentiate a method or constructor by the arguments it has and by the number of arguments it has. By default in C#, we should be used to having a empty constructor, like this one where there are no arguments, and then a fully qualified one, like this one. This is a fully qualified constructor because it has arguments. In fact, the maximum amount of arguments. So you have minimum and maximum, and the point of that is to give yourself some wiggle room. Alright, so last episode I foreshadowed the ability to have class variables or fields. So I can have private, static, integer, age. I can do that. That's a thing. And because it's private, age can only be accessed from within this class. If it were public, static int age could be accessed from here. We can say age. Oh, I'll have to write a hello world dot age. As you can see there, it appears as an option. But we're not going to do that. We don't need to do that. And part of the advantages of objects is that we don't need to do stuff like that. We can have flow control, we can have security. So what do I mean by that? So I mentioned also that a person or an object representing person is essentially a concept. It's the concept of a person. We have to instantiate it to actually make a person. So I could call this like George right here, and you'll see what I mean in a moment. So let's have ourselves some private field variables. So we'll have a private, and we're not going to write static here, and you'll see why in a moment as well, but we're getting there. So private string first name, private string last name, private integer age, and that's pretty cool. We've got these fields. These fields, because they are private, cannot be accessed without outside this class. And you're like, well, that's not very helpful. How am I supposed to get them outside the class? Also, how am I supposed to define them? Am I going to define them from here? Okay, well, that's not very helpful. How am I supposed to access these if they're private? You'll see. You'll see. So notice that I have first name and last name here. I'm going to make another constructor where it has even more arguments. So string first name, string last name, and int age. So I mentioned all that. Now, because this first one doesn't have any arguments, we should probably set some default values just in case. So we can say first name is equal to John, and the second name, so last name, is equal to Smith. Or actually, let's do John Doe. That's pretty good. And then age is equal to 30. I didn't mean to write those quotation marks right then. So these are the default values I set. So if I didn't feel like putting in any arguments, this is what I would get. This is what one would get when instantiating. So you can already guess how this is going to turn out. Let's make some methods, some accessors and mutators, from which we can obtain the values of these. So we'll have a public string get first name. Public string get last name. And for age, we can do public int get age. So that's pretty cool. We've got ourselves now the ability to fetch the age. So we could say console writeline, and I'm going to clone this a little bit. So we want the first name. Whoops, remember the parentheses because we're fetching it. George.get last name. George.get age. Whoops, here we go. And that way we're able to get the John Doe 30. Cool. Now, we named the object George, but we didn't set the name as George or whatever. So let's do that. Let's put in George. I don't know anyone named George or Irving. That's just a made-up name, as far as I can tell. That might be a real person. Who knows? So I did George Irving 45. Okay. So if we made our constructors just right, we should get these as output. What do you know? We don't get that as output. Why not? Well, let's go to person.cs. This is the constructor we had been calling because it has 3 arguments. And we used 3 arguments here. George Irving 45. But we didn't set the values. So when we call get first name, we're referring to first name, this one. We're not referring to the argument first name, because this first name right here that I have highlighted only exists within this context. It doesn't exist within the entire context of this class. So we need to make it exist within the context of this class. So we can say first name is equal to first name. Oh no, that's a problem, isn't it? Why is this a problem? Well, because this is one of the few cases where there's a problem with the scope. Within the scope of person, there exists 2 variables named first name. There's this one, which is available to everything in the class, within the class, and then there's this right here, which is available only within this context. So how do we tell the difference? If we want to refer to the one specifically from the class, we have to write this dot first name. Now we can tell the difference. So we have to do that for all the other variables as well. So what this does is says this first name, i.e. this one up here, is equal to the one defined within this constructor. And we do that for the subsequent ones as well. And we also want to do that here as well. Copy. Paste. This dot age. Note that we do not have a parameter for age here. We do have it for this, but age does not exist in this context. We don't actually need to say this dot age. We can just say age. And we can make it equal to a default value of 30. Okay, so what about these? Within the context of get first name, what first name is it referring to? It's referring to this one up here. It can't refer to this one or this one because those don't exist in the same context or the same scope. If you want, you can be ultra clear, even though it's not necessary. You could say this dot first name. It'll be grayed out because it's not necessary in this context to differentiate. Alternatively, you could just change this to first F and then L, and then you wouldn't have to make the distinction. See? Whoops. Then you wouldn't have to make the distinction here because then we don't need this. But just renaming this to something else can be a little bit confusing, even more so. And if you just change your variables to one letter, that's not helpful to anyone reading your code. Alright, so let's talk about one more thing that I didn't go over in the last episode. I didn't go over this in the last episode because I didn't deem it as important as some of the other things we were going over, but we should go over it now. So there's something called a comment in C#, and it's like this in other programming languages as well, but it might be different syntax. So you can create what is called a comment, and what that is a block or a single line of code or a part of code that is ignored by the compiler, that is not executed. So you could put a note for yourself like this, 2 forward slashes, and then you could say this is a note. It won't matter what the spelling is inside of this because the compiler will ignore it. And it's useful. You can use it to indicate what the point of some of these things are. So assigns the value assigns first name to the field of first name. That's pretty cool. You can do a little bit more than that. If you do 3 lines, 3 forward slashes, 3 forward slashes causes this to be generated. And what you can do is explain this is a method that retrieves age. Now, why might you want to do this? You'll see in a moment. If I hover over it, where it says get age, it'll say this is a method that retrieves age. That's helpful for when you're programming, but that little message you put there, because it's a comment, will not appear in the finished program. So it won't show up there. That's pretty cool, right? There are other ways to make comments as well. Let's be clear. So another way to make a comment is you can do a forward slash and an asterisk, and then you can go down a few levels and then put another forward slash, get rid of a space, and there you have a multi-line comment. This is a multi-line comment. So yeah, that's pretty cool. At least you might think so. Multi-line comments are pretty much the same in most programming languages. This, strictly speaking, is a single-line comment. You can also do things like you can also get away with things like this does not disrupt the code. That's pretty cool. What else can we do about person? Well, you notice we had to write all these get first name, last name, stuff like that. And that took a little bit of a while. And you realize if you want to set the values of those things, because you can't simply interact with first name outside of this class, right? If you want to mess with that, you'd have to create setters. So public void because this time you want to, like, for example, set age. So set age, and then you could put in int age. Then you could say this dot age equals age. You notice that's getting to be a little tedious. Like, isn't there a faster way of doing this? And you are right. There is a faster way of doing this, and I'll show you how to do that. Whoops, first name. Got a little distracted. I wrote last name, that's funny. There we go. So here we're able to set the last names. So what do I mean by that? So I mentioned you cannot mess with these outside of the class. So if I try to, let me show you what happens if I try to. Like, first, in order to mess with anything inside of an object like this, you have to use, in this case, the instantiation variable. So that's George. So if I want to mess with anything inside, I have to say George dot, and then it'll retrieve all the things that I can mess with. Notice I cannot mess directly with first name and last name. I have to say set first name to something else. And then I would have to Cakes McGuff. So that's how I'd mess with it. Now, if these weren't private, if these were public instead, then I don't have to use the setter methods. So I could then say something like George dot last name equals Goose or something like that, and then I could his name is now Cakes Goose 45. 45, I mean, being his age. But that's only if I make this and this public. I'm going to make them private. And the reason for that is with something like set age, I could control it. So what if I don't want to have a set age? Maybe I don't want people to directly set the age. Maybe I want it so that people can only increment the age. So private, so maybe I'll say like public void increment age, and then I can have an int age or number. No, actually, increment age, it goes up by 1 always. So this dot age equals age plus 1. So that's what increment age is. And oh, maybe I want to have another one where I can increase the age by a certain amount. So increase age, and then int amount this dot age is equal to this dot age plus amount. I could put this right here too. There we go. So I could do that as well. This gives me control. This gives me a sense of security. It gives me a sense of control, and it's kind of helpful. I can get away with a lot of things. I mentioned that, of course, I got rid of that. That won't work now, but I mentioned that person is the concept of a person. The instantiation is like the implementation of that person, or an instance of a person. So I can create another different person by saying like person Percy is equal to new person, and I could say something like Percy Billings. I don't know if anyone named that and they're 19 or something. And then I could compare the two. How might I compare these? Actually, I should go over if statements as well, but let's go over if statements. So if I want to compare two things, let's say I have like two numbers. Num1 is equal to 7, and another one is num2 is equal to 8. If I want to compare them, I could say if num1 is greater than num2, then number 1 is greater than number 2. I could do that. This is an if statement. So I can compare two things based off of which is bigger than the other, or which is smaller. I could also do equals. So you notice that I've been using a single equals symbol to assign a value. You would not use a single equals symbol if you want to see if they're exactly the same. So if you want to do exactly the same comparisons, so if num1 is exactly the same as number 2, you'd use two equal signs. So I can say number 1 is equal to number 2. That's neat. But these are primitives. Integers are primitive types. What happens if I want to compare something like a object? Well, some objects you can get away with it in C#. For example, I could create two strings. So name1 name2, and then I could say if name1 is equal to name2. Whoops, I want two equal signs. Remember that, that's important. Then I could say if they are in fact equal, it will trigger this condition and it'll say yes, they of course it will not say that because they're not the same. If I do that, it'll say yes, they are the same. Okay. So you can do that equalization right there. In some languages you can't do that. In other languages you have to say if name1 dot equals name2. You can do that as well and that works in Java as well. Now for other objects you might not be able to get away with that. So let's try these two people, right? We made two persons, George and Percy. So we can say if George is equal to Percy. So are they in fact equal to Percy? They are not equal to each other. And it makes sense. I mean, they have different values. But what happens if I create like a George 2? So person George 2 is equal to George. And then we compare George to George 2. What happens then? It says yes. So what happened was that we took the reference, we took the location of George in memory, and we applied it also to George 2, and that makes them equal. Right, so I mentioned earlier that using setters and getters, this is a setter, this is a getter. I mentioned that writing setters and getters is a bit verbose, and it takes a little while. As you can see, it took us a while for just 3 variables, and not all of them needed it. I mean, the age, we ended up not having a set age. We just had a increment age, increase age. But that took a while, and these setters, the setters and the getters part could have been made a lot faster. So there's an alternative way of doing it. So we're going to create a new person class. we're going to call this actually employee. We're going to call this the employee class. I'm going to get rid of that stuff at the top because we don't need that. So let's make this a public employee class. It's good practice to do so. And we can say public employee. And we've got ourselves an employee. Let's create some private variables. So string first name, private string last name, private int age. And we can also, if we want, put in a private string title, like job title. Alright, so we've got ourselves this employee. We can say public oh, I should note something with person, right? So I pointed out that there's default values here. If we use the default person object, we could say person Gaius equals new person, but we don't have to put in any arguments because we gave it that option. It's going to just have the default values of, unfortunately. But there is a way around that because we created setter and getter methods for ourselves. So we can say Gaius.set first name. Gaius.set last name is equal to and we can say Gaius dot, well, we can't really set the age, we can increment the age a couple times, maybe. You might be wondering, why doesn't this work? Shouldn't I just be able to do it? Because these are methods. I did that to see if you were still paying attention. So that's how you'd set the value of Gaius and then Gordonson, and we can increment the age, and now we'll show a different age. Alright, so now we go over to employee. We can do the same thing. We can have setters and getters like we did in person, or we can do something a little bit different instead of having setters and getters. So what do I mean by that? Well, we can have something called properties. So what are properties? Properties are a thing that are unique to C#. They don't exist in Java. Properties do not exist in Java, but they do exist in C#. And what it is an alternative way of doing it. It allows us to not have to make setters and getters. So what do I mean? So I can say, for instance, public string, and I can say first name with a capital F, and then I can do this. So this is an opening and closing curly bracket set, and I can say get, and first name equals value. Oh no, excuse me. For get, I can write return first name with lowercase f. And then for set, I can put first name with a lowercase f equals value, the keyword value. So what this does right here, this block of code saved me the trouble of writing a setter and a getter for first name. So there's no get first name, set first name. Instead, I just have this. So how will this look like? Well, okay, let's create a employee object. So I can say employee e equals new employee. And notice, within employee, I just have this empty constructor. There are no arguments. I don't have any other constructors, so I have no other way to set values. But I can set the value and look at the value of first name because I have done this. So first name appears. It looks like a wrench. First name. And I can set that equal to something. I can't refer to last name yet, but all I have to do is create a property for that. Public string last name, and I can say get return last name. And I can also make a setter if I want to. Last name is equal to value. And you might be wondering, well, what if I still want the getter functionality for age? You can still do that. You can say public int get age, and then in there you can say in there you can write return this dot age. You can still do that, and you can make your weird increment age functions. You can still do this if you wanted, and that would be fantastic. That would be amazing. So if you look at employee, I can say employee dot increment age, increase age. That's awesome. I can also do last name is equal to Cortez. That's a mismatched name, but whatever. So I can say console.writeLine, and if I want to refer to the first name or to the last name, I can say e dot first name, and I can put a space in it. Say e dot last name. Edmund Cortez. That's awesome, isn't it? Look at that. We've accomplished so much. Now, you notice employee and an employee and a person are not that dissimilar from each other. They're pretty similar in terms of makeup. Why should we rewrite some of this stuff? What if we could just write a line of code that says, okay, employee is based off of person. There can't be an employee without there being first a concept of a person. So what we can do is write employee, make a colon, and then person. So what this says is employee is based off of a person. And I think we can get rid of first name, last name right there. And it will complain. Right, because it is private, but we could do protected. Right here, protected is in between private and public. See, it still allows it. Because even though this is from person, this was only defined in person, it being protected means, okay, can't look outside the class unless that class is derived from it. You see, employee can look at it, because even though employee is a different class, it's based off of person. So that's the advantage of that. Now this, of course, this age right here is defined within employee. We didn't set a way to make an age, did we? No, we didn't. We also didn't make any extra we also did not make any extra constructors. What if we want to we've been able to get things from the other classes. What if we want to get them other places? So actually, we don't even need to write this stuff. Get age, increment age, increase age. right? Because I have a feeling that because employee is based off of person, we'll still be able to see it. You'll see what I mean in a moment. So I can say E. I can still increment age. And you may be wondering, how is that possible? You don't have it defined in here. There's no increment age in employee anymore. It's because employee is based on person, and the methods defined in person that are public are going to flow through to employee as well. So that's awesome. What other things can we get away with? We can do a lot of nifty things. How about the constructors, right? So we have a constructor in person, first name, last name, age. But we have only the empty constructor in employee right here, which is the employee constructor. Can we put more arguments into it? Let's find out, right? Let's find out. So we can say, let's create another employee. We're going to call this Ronald Swanson. It's going to be equal to new employee. And it looks like we can't really get away with some of this. What if we wrote Ronald Swanson? And I think he's 54. I don't know how old he is in that show. Well, it won't let us do that because employee does not have that constructor. What if we wrote person? Doesn't like that either. Does not like that either, but maybe we can just write, that's okay. Oh, isn't that interesting? So we are able to put a cast there to allow us to use the person constructor, which is only existed in person. We can do this because employee is based off of person. Of course, we have to use this constructor. So let's find out what we get when we do that. Ronald Swanson. Let's do a right line statement, and let's say Ronald Swanson dot get last name, Ronald Swanson first name, and notice I'm using this right here. The get last name is defined in person. As you can see, it says person right there, but first name is defined within employee. See? It's really interesting. Let's see what we get. Ooh, it did not like this conversion we tried to do. Invalid cast exception. Unable to cast object of type hello world basics.person to hello world basics.employee. So, unfortunately, these aren't actually the same thing. We try to fool ourselves into thinking they are, but they are not. It's a bit like, well, let me show you another example. So all objects are based off of an object called object. There's this object called object. I can make an object of object and equals new object. And that initializes the object class. And these are the only methods we can get from it. And you notice that Ronald Swanson has equals. It has get type. It has toString. So all objects are descended from the common object called object. But you notice when I define person, I didn't have to write because it's not necessary to write that because it's a compiler optimization. In fact, I don't have to say it derives from object is a design choice in the language, even though they are technically all derived from it because of the toString method. Okay. I encourage you to like and subscribe to get more content. Press the bell notification to receive word of when a new video has been uploaded. And I encourage you all to have a fantastic day.